Hello, everybody, and welcome again to another issue of our great seminar, Connect Them All in Internet of Things. My name is Anna Faust, and I'm organizing this seminar series together with my colleagues Pietro Manzoni, Frederica Algren, and Marco Zenaro. And today we have a special guest. We always have very special guests. This is Carlo Boano from TU Graz, a good colleague and friend of mine. So I'm looking forward to a great talk. The floor is yours, Carlo.
Thank you very much, Hannah, for inviting me and having me here today. Hello, everybody. Actually, as you can see from my slides, today I'm going to talk about IoT and sustainability, two buzzwords that are very popular nowadays and that are frequently associated together. In fact, we often hear from the media or from the news headlines like these ones, the IoT will save our natural resources, or a smarter world will be more sustainable. Where the smarter world, of course, refers to a world filled with smart objects, which are all the connected devices forming the backbone of the Internet of Things. And the other example of such headlines are that the IoT will help us fighting climate change, or that connected technologies are going to help us decarbonizing the world. And we know that actually this is partly true. So IoT solutions can in fact already be used to reduce CO2 emissions, for example, in smart cities, by optimizing road traffic and by reducing the amount of wasted energy in buildings. Now, just for fun, since everybody's using ChatGPT nowadays, I've also tried asking ChatGPT a comment about IoT and sustainability. And the answer I got was strikingly similar to the headlines we have just seen. Namely, that the Internet of Things has the potential to play an important role for sustainability, helping to reduce resource use and increase efficiency. And this is because IoT-enabled devices provide the ability to monitor and control energy and water use, manage waste, and track emissions in real time. And as the technology continues to mature, IoT-enabled systems are becoming increasingly capable of providing the data and the insights necessary to create more sustainable systems. And in this talk, I will start from here. I will start from the IoT being a key enabler for building sustainable systems and improve sustainability in general in what seems to be a perfect match. But as we all know, all that glitters is not necessarily gold. And in fact, there is a paradox when putting together IoT and sustainability. On the one hand, the IoT can help us building smart cities, increasing awareness into resource usage and promoting a more responsible consumption of energy, therefore improving sustainability. But on the other hand, sustainability itself is often not a concern during the design phase of an IoT system. We still don't really design IoT solutions with sustainability in mind. And the result is that most IoT devices end up as electronic waste after a very short lifespan. So in this talk, I'm going to discuss this paradox, showing concrete examples of why IoT devices become useless way too quickly, and trying to understand why this is the case and trying to highlight some possible solutions for that. So this is not going to be a detailed technical talk, but rather a reflection on current IoT trends. So let me start by making a step back and by thinking about how the IoT has evolved over the years. So actually, the IoT has a very short history. I mean, it's about 30 years ago that the first everyday object was connected to the internet and became smart. This was a toaster, a remotely controllable toaster that was presented by Romke and Hackett at the Intertop conference in 1991. So this smart toaster could be switched on and off remotely over the internet. It even had a robotic arm which could insert and remove the toast slice remotely. So this was the very first known example of everyday object connected to the internet. And actually, if we um, don't consider just the internet, but also the predecessor, so the ARPANET, we could even go back to 1980. And this was when four students at Carnegie Mellon University connected the campus Coke machine to the ARPANET because they wanted to check whether the machine was filled with bottles or not without having to physically walk there. So anybody could actually type finger Coke at CUMA and they could check if there were bottles in real time or not in the machine. So actually, we did start to create smart objects already by connecting them to the internet, even before we even talked about IoT, right? Because the term IoT was coined much later. It was for the first time mentioned in 1999. This was by Kevin Ashton, the co-founder of the Auto ID Center at MIT. And Ashton referred to an Internet of Things during a presentation where he was trying to push the idea of using RFIDs in a company's supply chain. So he was trying to argue that connecting industrial products to the internet would help improving their logistics and tracking. And at that time, so when actually for the first time we heard about Internet of Things, the internet itself still had a very small penetration. The explosion actually came in the next decade because it's between 2000 and 2010 that the number of connected devices exploded and it even surpassed the number of people on Earth. And Cisco actually is estimating that this happened around 2008, and that's the moment that Cisco considers as the beginning, the official beginning of the IoT. And around these years, in 2011, Cisco actually published a very influential white paper called The Internet of Things, How the Next Evolution of the Internet is Changing Everything. And this white paper contained a very famous infographic. I'm sure that many of you have seen it before. It basically describes a world in which everyday objects start to talk to each other and develop their own intelligence. A world where your alarm clock is connected to the internet, it gathers traffic data, it talks to your car, it even talks to your coffee machine and other home devices. And so, for example, it knows that you can wake up a bit later. It even turns on your coffee machine at the right time for you so that you can enjoy a warm coffee when you get up. And now Cisco say that all of these will become reality in a decade. So we actually should expect 50 billion devices by 2020. Now, of course, we can debate about the actual numbers. I mean, whether this was really reached or not. I mean, these are anyway just estimates. But what we can all agree on is that the vision has become reality by now, because we do have internet connected coffee machines, which can communicate to our wristbands, which wake us up in the morning by vibrating. And these devices are available in the market, together with plenty other devices which can make our homes smarter, from smart speakers to smart thermostats, smart door locks, smart light bulbs, and so on. And according to recent statistics, indeed, smart homes and wearables are today some of the most fruitful IoT market segments. And that's not the news. I mean, if you just watch around, you can find all these devices that are ubiquitous nowadays. But this is just the beginning, because Cisco already revised its vision and stated that we should expect 500 billion connected devices by 2030. And so the number of IoT devices is going to blast in the next few years. We should expect a ratio of 60 connected devices per person in 2030. And 2030 is coincidentally also the year by which we are expected to address several urgent issues in our world. And this is because the United Nations has formulated a so-called 2030 agenda with concrete goals to ensure a better present and future for our planet and for all of us. And these are the so-called 17 Sustainable Development Goals, which you can see listed in this slide. And they aim, among others, to protect our planet and its natural resources, but also to create the conditions for sustainable economic growth and shared prosperity. And the 500 billion IoT devices are supposed to help us achieving many of these 17 goals. For example, one of the sustainable development goals is to build more sustainable cities. And this is very important because we need to address the increasing urbanization. By 2030, 60% of the world's population will live in cities, and many megacities will have more than 25 million inhabitants. And we urgently need to make these cities greener because they account for 75% of all CO2 emissions on our planet. And of course, what we can do is to leverage IoT solutions. We can build smart cities by reducing the amount of wasted energy in buildings with demand driven heating and cooling. We can improve waste management and street lighting by adding sensors everywhere, which can enable on demand illumination or waste collection. We can optimize road traffic for a more efficient and environmental friendly transportation, or we can monitor and control the environmental pollution and the quality of the air and of our life throughout the city so that the municipality can take the corresponding actions. And we already have many of such systems available which can be readily deployed and that can help us achieving this goal. Another key sustainable development goal addresses the availability of water. And this is because almost half of the world's population still lacks safely managed drinking water. And the issue here is that, especially for developing countries, millions of cubic meters of water are lost daily. And they are lost because of leakages in the water distribution network. And what IoT technologies can do for us, they can definitely do, is monitoring the water pipes on a very large scale, and they can actually detect the leakages in real time. And if we can do that, we can of course avoid that the precious drinkable water is lost. We've actually done some pilot projects in our group a few years back using LoRa technology to monitor the water pipes in rural areas and to detect the leaks in real time, and this worked out pretty well. And nowadays, there are many more solutions for water management available. And they do help tackling similar problems. For example, avoiding to waste water for irrigation, for example. Now, when talking about irrigation, another common IoT application is precision agriculture, or also called smart farming. And these applications are meant to help us improving our practices. So we want, of course, to reduce water during irrigation, so at least not to waste it. We also want to reduce the amount of fertilizers because we want to minimize the environmental footprint. And ultimately, we want to also increase the crop yield because one of the goals that at least partially we want to address is the so-called zero hunger goal. And IoT solutions can actually help us doing that on the one hand by increasing the crop yield, but also by better tracing the goods, so improving the food supply chain. Because unfortunately, a third of the world's food is lost after being harvested. It doesn't even reach the retail market. And therefore, tracing of goods from producer to consumer is very, has a huge potential here. And in general, the better tracing of goods and products is actually linked also to another of the goals, which is improving production processes, so like asset tracking or preventative maintenance or remote monitoring. And this is one of the goals because we want to digitize industrial processes and make them more efficient as well. So this is also one fundamental sustainable development goals. A lot of them, actually, a lot of the goals in the 2030 agenda deal with preserving the Earth's natural resources and with mitigating the effects of climate change, both on land and below the water. And here, once again, IoT systems and sensor networks in general, they are fundamental to achieve these goals. Because, for example, you can predict or perform some kind of early warning for all sorts of destructive events, from flash floods to forest wildfires or to rock falls. And of course, this is essential to mitigate harm not just to humans, but also to civil infrastructure. And this is, of course, one of the big assets of IoT. But IoT also can play a role in preserving the natural resources. We talked already about avoiding water waste, but there are many other systems deployed out there which can, for example, also monitor the quality of the water itself. For example, detecting toxic spills into rivers or into the sea. And this is, of course, also very important because you can preserve the habitat of marine species and making sure that you can conserve them as well. And finally, another key goal in the 2030 agenda of the United Nations is to improve the people's health and well-being. On the one hand, we have to deal with an aging population because by 2030, 1.5 billion people will be more than 60 years old, and this is going to increase the pressure on the health system. And on the other hand, the number of chronic and non-communicable diseases are increasing. So we need to detect, to screen, to monitor, and to treat all of them as early as possible. And of course, all the wearables and IoT technologies on the market are again an asset because they allow 24/7 monitoring of the vital signs, also when the patient is at home. And of course, this is relieving the load on the health system, while of course allowing an early detection of diseases. Yeah, so far so good, right? It seems that these 500 billion devices are going to help us meeting all the goals. So yeah, the road to 2030 is absolutely bright, right?
That sounds amazing. I hope it will work out.
Yeah, I mean that's what we all hope, right?
Yeah.
Unfortunately, I don't want to play the bad guy here, but I already mentioned that there is a paradox, right? And that's now the second time, well, that's the second part of my talk, because there is another phase, right, of IoT and sustainability, and this other phase is connected to the Sustainable Development Goal number 12, which focuses on a responsible consumption and production. So this goal refers to the use of renewable energies, to the reduction of material consumption, to the need to reduce the amount of generated waste. And among others, electronic waste, or e-waste in short, is a big problem in our society because it's very hard to recycle electronics. And here are some figures. Every year, we generate 7.3 kilograms of e-waste per person. So if you actually would put it all together, you could actually manage to fill a line of cruise ships that is 125 kilometers long. And this is just the e-waste we produce in 1 year. And and this amount actually is just going to expand because the use of computers, smartphones, and all kind of electronic devices is going to continue to expand, right? The problem is that e-waste is extremely dangerous for our health because it contains toxic components like mercury, lead, cadmium, barium, lithium, polybrominated flame retardants. I mean, there are plenty of toxins which can lead to permanent health damage. And the problem is that most of the e-waste from the industrialized nations is actually being illegally exported to developing countries. And actually, it ends up in landfills. And all the toxic chemicals are released. They impact the air we breathe, the water we drink, the soil which is producing the food we eat. And this is very bad because the pictures that you see in the slide, they are taken from the famous Agbogbloshi digital dumping ground, basically in Ghana, which is sadly one of the most famous in the world. And this is because in this dumping ground, every year millions of tons of e-waste are processed. So now, in light of these, let's go back to our 500 billion IoT devices, which will soon be around. How are we going to dispose of them? Um, 500 billion devices is a big number, and it's no surprise that this starts to become a concern. And now you can also see some additional headlines here as well, right? And these concerns are justified because at the moment, if we really want to be honest, we are not really trying our best to make sure that IoT devices can last as long as possible. We are not really making sure that we can prevent an early disposal. Actually, on the contrary, the faster an IoT device becomes obsolete, the better, because then you're going to buy a new one, right? Companies can increase their sales. And
And
so
they're
what
so
happened?
cheap, and we're always about cost and the
Exactly,
small size. And I have just to think about how many those devices we trash in our lab.
exactly. And so, unfortunately, we have to admit that a lot of IoT devices become e-waste way too quickly, right? Um, and actually, what I want to try in this talk is to identify a number of key reasons for why this is the case. And I'm going to enumerate a couple of them. And the first one is actually that we are designing a lot of trash. I mean, let's face it. If we take a look at the smart devices which are being commercialized today, we find a lot of unnecessary stuff. Okay, so if we just Google a bit, we can find smart bottle openers, which can count the number of bottles of beer we open with an accelerometer, and then they post this information on social media. We can find smart toasters, which can send a notification to our smartphone when the toast slice has reached the desired level of crispness, right? We have smart kettles, which do the same. They tell our smartphone the water is boiling now. So there are actually plenty of products for our kitchens. We can even find connected egg trays, which notify us when the number of eggs, so how many eggs are left in the fridge, basically. I mean, we can find smart salt shakers. Instead of pressing the button, you can activate via voice. So there is plenty of this, and there are also like connected sex toys, even smart hair brushes that they are measuring the speed of your strokes to make sure that your comb your hairs very correctly. I mean, yeah, nice gadgets, right? Um, but probably we can live without them as well. And and the issue here, I think, is the mindset, because we are prioritizing profit over usefulness. And there seems also to be the idea that IoT devices, they are made to make our life more comfortable and easier. And typically, that's what you hear when you see the marketing of smart objects. Yeah, don't take the key out of your pocket. The smartphone can open your door lock for you, right? There is no need for you to put effort, right? And also, if you think about the history of the IoT, I mean, I just presented it before, right? What were the first ever smart everyday objects which were connected to the internet? A toaster, a Coke machine. So not exactly examples of something really useful to our society. And even in the Cisco infographics, what did they use as an example to show how attractive is the IoT going to be? A smart coffee machine. So again, there seems to be a wrong mindset, at least in the general audience. And this is actually a plea to all the IoT enthusiasts out there. When you design products, make sure that they are useful for the society, that they can actually help to reach one of the sustainable development goals. Because our daily comfort should not be the priority. So this is actually one of the first things that we should do to reduce the amount of e-waste. And another problem is that we often have a hard time disposing of these IoT devices correctly. Because also on the internet, if you browse a bit, you often find questions like this one. How am I supposed to recycle them? It's a good question, because if you think about everyday objects, actually the electronics is hidden inside them. That's why they are smart objects, right? They are just common objects, it's just that they have more functionality. And sometimes you cannot even extract or remove the electronics or even remove the batteries, because it's just hidden together with the rest, right? And so ideally, you are able to separate electronics and batteries from the rest, and then you just recycle them correctly. But typically, this doesn't happen. So you just throw everything into landfills, and this is again plenty of toxic chemicals. And by the way, it's even worse because batteries can cause fire or explosions if you don't dispose them properly. And so, an important recommendation here: if you are designing an IoT device, make it easy for the user to simply separate the components and recycle them properly. This is again something that we are not thinking about that yet, but we should. So these are the first kind of two golden rules. Avoid producing e-waste by producing something meaningful, useful for the society, and make sure that it can easily be recycled. It's not difficult, but it's a first step, okay? But then it's also very important that when we design things, we design them well, because there is nothing worse than something poorly designed, which doesn't really work well, which is not reliable, and it's very likely to be thrown away very quickly because it doesn't work as I expected. And a common example of poor design when it comes to IoT products are products whose software cannot be updated. This is actually a major design flaw. And unfortunately, many devices on the market today, they still don't support any kind of over-the-air firmware update capability. And this is bad. It's bad because a product cannot keep up with the new features. So if you can update it, you can address some changing customer demands, for example. And of course, you can prolong the usable lifetime. It's bad because you cannot fix software bugs. You cannot improve performance over the years. And again, this would prolong the usable lifetime of the device. But even more important, it's bad because one cannot fix security vulnerabilities. And if a device becomes vulnerable to attacks, then you have no options. You have to throw it away. If you keep a vulnerable device active, you just ignore it, actually what might happen is that it gets recruited into botnets, and botnets can perform distributed denial of service attacks. For example, IoT botnets like Mirai, they have put down fundamental internet infrastructures already, services. I mean, for example, they took control of vulnerable IoT devices, thousands of them, and then they used all of them together to issue thousands of requests to domain name servers so that they get overloaded and then basically they fail. And what happened because of this is that major websites like Google, Amazon, Facebook, Netflix, name it, they basically were offline for half a day or even more. And so uh, actually, it's not difficult. You just need to make sure that you can update the firmware. A common excuse here is that many of the devices, they are so tiny. You only have a few kilobytes of RAM and flash memory, so there are so many constrained memory capabilities that there is no space for that. Well, this is not true. Okay, we actually have done it ourselves in our group. We made a portable and lightweight software update framework. It's called AppKit, and this works with all the popular IoT operating systems: Contiki, Riot, Sapphire. It supports all the constrained platforms. It requires only 20 kilobytes of RAM, and it does all it should. It includes different crypto libraries. It supports the so-called push approach. Push approach means that the smartphone, for example, can inform the smart object, hey, there is an update. It also supports the pull approach, and the pull approach is where the smart object checks itself, is there an update, and downloads it on its own. Both of them, they can be supported with less than 20 kilobytes of RAM. And AppKit is open source, and there are many other open source frameworks. So the message here is use these frameworks and make sure that you embed some over-the-air firmware update functionality in your device. Otherwise, it's very likely that it will become unusable too quickly.
Very nice, very interesting work. There are some questions which came in, especially about the recycling part. I think that impressed many people here. Is there actually some kind of a law regulations that the producers of IoT devices have to declare how they recycle how they recycle the products and such things, or everybody can produce whatever they want?
I'm not aware of specific regulations, but the main issue here is that very often the way you recycle is left to the user. And the problem here is that we need to incentivize, or at least to put the user in the condition to easily, no effort, do the right thing. And that's something where the regulations don't really kind of specify anything. As long as you have some formal parameters, you're good to go. And what I really meant here was put the user, the end user, in the condition to just, okay, battery goes here, it's extracted, and basically it's correctly recycled. So that's something which is not really yet, at least to my knowledge, not really mandated by the regulations.
Okay. There are two other quite critical questions, I would say, kind of contradicting what you're saying.
Yeah.
One is whether those idiotic inventions are actually not the key to finding really practical solutions and to find also maybe to create innovation.
I mean, of course, it's always good to create something new to show what is feasible, because by doing that, you, as you say, you create innovation and you kind of expand the potential of the technology. So this is absolutely true. The problem is that we are now, at a stage where the technology is sufficiently mature. We already have, as I said, smart city solutions. There are plenty, and these can really make a difference. A smart hair comb, at least if you ask me, that does not make a difference. And
I fully
at
agree
least,
with you. That
at least
doesn't
at,
make
at this stage, I would rather move my design effort to something else. In the beginning, this is right. Maybe also for fun, we investigate the smart toaster. Sure, we should look what you can do. This I completely agree. But now we are already in the IoT era, and now we need to change mindset, and that's what I meant with that.
okay.
But it's right. In the beginning, in the 90s, when Romke and Hackett showed, hey, there is a smart toaster connected, at that time it made sense because it shows the potential. But now we are already in a different stage, right, in the history.
Okay. And another critical question is whether if we let's say achieve a longer lifetime of the IoT devices, whether we are actually not hindering innovation again, because then the lifetime is so long, that you cannot create real innovation anymore. You can update a little bit, but no real innovation.
This is a good point. So, of course, it's a paradox as well, right? If you try to keep something for longer, then you prevent something newer to happen. Um, yeah, I mean, it's correct, but at the same time, there are products which are designed for a purpose, and the purpose remains. So, as long as the purpose is fulfilled, and I'm thinking, for example, about uh, monitoring of different quantities, like physical quantities, unless you can do it more precisely and better, and then of course this would justify a new revision of the hardware. um, I mean, it's hard to basically argue that innovation is really needed. I mean, of course, it's true, you can always
Mhm.
make things better. The question is it sufficiently better to justify changing hardware and basically
Is the next generation
exactly
camera for your smartphone really that
right,
important
exactly,
to change
exactly.
your smartphone every 6 months? And so
If
this
I
is
have
like,
8 megapixel, doesn't make a difference
yeah,
if I have 7, right?
yeah,
So
that's very
if
point.
you ask this question, then of course no, there is no point. Nobody prevents me to try to go to 50 megapixel. Then of course we can think about it.
Yeah,
But yeah, it's always a matter of balance, finding the right balance between exaggerating, and I have the feeling that we are, versus innovating, and we always should innovate, of course.
yeah. And coming back to your slide, currently here there is a very short question whether UpKit can also support update over LoRa.
Um, we actually designed it for BLE and 15.4, so not for LoRa, but I mean the library can easily be ported, so that's not
Cool.
it's not yet done, but it's not too difficult actually, because basically
Okay.
you have a set of libraries that you can port to the necessary radio.
Okay, so it's doable. There is no real
You
hindering, like kind
no
of a design problem of that.
no,
Okay.
because actually the key there was to keep the libraries small. This was the main goal, to show that even if you have like a low power device, you could do it, and this is done, and it can also support lower devices.
Okay, great.
Just it doesn't support in the current version.
Okay. I have been distracting you for quite a long time, so let's proceed with
No problem. I
with
mean,
your
feel free
topics.
to interrupt. Feel free to interrupt me anytime. So
It's okay.
yeah. So as I said, one design flaw which may hinder the durability of a IoT device is the lack of software updates. Another design flaw, or another common problem in the design of many IoT systems, is that they don't communicate reliably. And this is something that for connected devices, not being able to communicate reliably, well, that's not something very good, right? And this especially applies to wireless devices. So imagine you have a smart light bulb. Well, you don't want to press 5 times the button to basically switch on or off the light, okay? And unfortunately, the problem here is that wireless devices, they often share the same frequencies. For example, all devices using Wi-Fi, Bluetooth, BLE, Zigbee, OpenThread, and many others, they all share the same 2.4 gigahertz ASM band, and therefore they can potentially interfere with each other. And interference means that packets are lost. So, for example, your commands to the smart light, which means you need to retransmit them, which means you're wasting your limited energy budget, you're increasing latency, and of course, the user might not be happy about that. But interference does not only come from nearby wireless devices, it may also come from surrounding home appliances. For example, also microwave ovens, they happen to emit noise in the 2.4 gigahertz range. And they actually do it in a very powerful way, so actually they destroy pretty much everything. And this is the reason why it's very common that wireless devices, they don't work reliably and that they frustrate end users. If you take a look at the web, you find many people complaining, my smart home device doesn't work properly. I mean, even if you take a look at the Amazon Echo help page, the first item entry is, oh, if you're having Wi-Fi issues, then make sure that your device is far away from any device that can cause interference. Yeah, I mean, thanks.
Which that's almost impossible nowadays. I
Exactly,
mean,
exactly. If you can, of course, please try to put it away from anything. But if you have neighbors which have plenty of devices, probably there is not much you can do, right? And
mhm.
so yeah, and then if your device doesn't work persistently, then probably you're gonna throw it away. Now, luckily, there has been a lot of research on how to build reliable networking protocols which can adapt to RF noise and cope with RF interference in this band. But one has to pick them. So, unfortunately, on the market, I still find tons of solutions which are using protocols from 10 years ago, and there is a huge performance gap between those ones and the protocols which have been developed like in the last couple of years. And so one needs to make sure to select the newest networking stacks and protocols. Um, and it's not just about losing packets, because of course it's important to be robust to interference to make sure that we can communicate, but it's also essential that also all the services around the communication are working correctly. And one example of such services is localization. And let me show you just an example. So why this is important. Let me take ultra wideband because it's one of the most popular devices for localization nowadays. Um, ultra wideband devices, they have a very good time resolution. And so this means that you can send the nanoseconds pulses. And because of this, you can basically achieve a centimeter accurate localization and tracking. And so they are perfect to build indoor location aware IoT applications. And actually, they don't even operate in the 2.4 gigahertz band, because which is good. They operate in the 6 gigahertz range, and because of that, they said, look, we are interference free. Bad luck, because since 1 year, since 1.5 years, there was a new Wi-Fi standard called Wi-Fi 6E, and guess in which frequencies it operates? It operates also at 6 gigahertz, and the difference is that it operates at a very high throughput. Here is actually just a picture about the Wi-Fi 6E channels. There can be either 20 megahertz or 160 megahertz bandwidth. And if you also add the ultra wideband channels, then you see that they exactly overlap all over the place. Actually, there is even one channel number 7 of ultra wideband which is overlapping with all the Wi-Fi 6E channels. And what's the problem here? The problem is that Wi-Fi 6E devices, they use a transmission power of 27 dBm, and ultra wideband devices, they are low power devices. And this is logarithmic scale, right? So you can easily expect that ultra wideband transmissions are going to suffer a lot if there is any kind of Wi-Fi 6E traffic. So we actually studied it ourselves, this coexistence issue. In our group, we have set up a testbed with both ultra wideband and Wi-Fi 6E devices. We put them across a large hallway and across offices in our university. So the picture here gives you an impression of our setup. And what we do is we simply let ultra wideband devices broadcast packets, while the Wi-Fi 6E devices, they exchange data with each other, either using iPerf or by streaming a YouTube video. And then we measure the PRR, the packet reception rate of all the ultra wideband devices in the area. So we know how many packets were actually received out of those which were transmitted. And guess what? Our results are showing a sad reality, which is that all the communications ultra wideband devices, they are strongly affected by Wi-Fi 6E traffic. So in average, across the entire hallway, we lost 66% of the packets. And all the devices which are actually close to the Wi-Fi 6E transmitters, they actually didn't even get a packet through. So it was just completely dead. The PR was 0. And this kind of unreliability has actually very strong implications on the correct functionality of localization systems based on ultra wideband. Because what we've seen in our experiments is that they basically become useless. We could only locate successfully 1% of the time, which is, well, not very much. Now you can wonder why this is the case, and I just have a very easy illustration for that. Consider a classical positioning system like you are being navigated in a shopping mall. Typically, you have a mobile tag, which is the green circle over here, and you are entering an area. There are typically some anchors, static anchors, which are deployed to help with localizing yourself, and these are the red circles over here. And typically, what you do as a mobile tag, you start communicating with the anchors, with the nearby anchors. And you do that by following a protocol which is called two-way ranging. It's like a two-way handshake. You send a message and you get it back. And based on this two-way handshake, the tag estimates the distance to each of the anchors. And then you combine this information geometrically, and then you triangulate and know where you are. Okay? So typically, you combine the information from at least 4 anchors, and then you can derive the position. Now, if a Wi-Fi 6E device starts sending traffic, it's very likely that it destroys pretty much all the two-way handshakes, okay, between the tag and the anchors. And if you have an average packet reception rate of 33%, which is the one we had in our experiments, this means that the probability to successfully contact all the four anchors is 0.53 to the power of 4, and this is 1%. And of course, what you can do is you keep trying, right, until you manage to talk to the anchors. Of course, you can try until you get an answer. This is possible, but this doesn't work with localization systems, because in localization systems you need instantaneous distance estimates from all the anchors. Because what happens is that if you first get a message from anchor 1, and then it takes 2 seconds to get another one, and then 5 seconds to get the next one. In the meanwhile, you have moved by several meters, and when you try to basically merge or triangulate, you are doing it with inconsistent information, and so your accuracy will be pretty poor. Yeah, so what can you do? I mean, I'm not going to go into detail, but for the specific case of ultra wideband and Wi-Fi 6E, there are ways to improve your communication protocols. Actually, in our group, we have proposed a number of solutions, a revision of the protocols, and you can at least improve the performance a bit, such that you can at least manage to sustain some traffic, even though Wi-Fi 6E traffic is there. So if you're interested, you can take a look at our papers. But the lesson here is make sure to always use the state-of-the-art protocols, to always adapt to environmental conditions. Otherwise, you're going to suffer such a poor performance that your device will be very likely dismissed. Okay, and this applies to RF interference and all other kinds of environmental impact. For example, even temperature variations have an impact on the quality of communication. It turns out that when it's hotter, the signal strength decreases, and actually you have to do a lot of things to make things properly. If you don't, if you just say, yeah, for the sake of going into the market, I just take the first protocol stack I find and ship it, yeah, then bad things may happen. Okay, so this was this poor design and reliability of the solution. Now, another key issue leading to a lot of IoT of e-waste is the limited lifespan of most IoT devices. And the limited lifespan, we talk about it, right? It's often caused by the so-called planned obsolescence, which basically means that the device is explicitly designed to become outdated quickly to be replaced with a new one. And we discussed it, right? Smartphone are a clear example of this. We always get offered a new generation device with many more features, with a much higher performance, maybe even a nicer aesthetics. And so what we do is we throw away the old one and we get a new one, okay? A side effect of this is that newer devices typically are only compatible with the latest technologies and products on the market. So this means that if you by any chance still own a very old product, you actually may be forced to replace it. And here is an example of this. Imagine that you have a smart home with 4 devices, like ABCD. Each one is using a different wireless technology. And imagine that you have a central hub, like a smart speaker, which allows to control all of them. Now, suppose that you replace the smart speaker with a newer one. And let's imagine that the new smart speaker only supports technology BCD. And technology A is now too old, is not attractive anymore. So it's no longer supported by the new smart speaker. Now, what do you do with the device A? It's still fully functional, but what do you do with it? Well, it's a rhetorical question. So very likely you're going to replace it with a newer one. Or you don't want to throw it away, but then you have to buy some adapter, some gateway, which still allows you to connect. So in any case, you would still buy yet another device. Okay? So more device, more e-waste. And considering the speed at which IoT technologies evolve, this is actually not so uncommon, right? Even worse, it may happen that the device stops working from one day to another. And this has nothing to do with the fact that you have changed the device. This is the so-called sudden obsolescence. And the reason for that is that IoT businesses are very volatile, because nowadays we have so many startups being founded, and as a consequence, also so many startups going bankrupt after a very short time. And it's not uncommon that as soon as the startup goes bankrupt, the device stops working. There are many examples of that, unfortunately. And a typical example is the one you see in the slide. So the company has financial difficulties. It stops managing the cloud service. all the devices required the cloud service, you can throw them away. If you Google a bit, you find many cases like this, from thermostats to IoT gadgets like mini printers. There are many cases like this. So what is the problem here? The problem here is that for the sake of simplicity, in the programming, in the design, we are hard coding a device to specific service. And when a device is hard coded to specific service, it's beholden to that service being available. And therefore, an important recommendation here is make sure not to bound the functionality of the device to hard coded services, unless it's strictly necessary. Or in alternative, at least allow some migration to different types of user-owned services through a firmware update. Okay, so a company may go bankrupt. A company may also be acquired. It may be bought by another company. And it's not unlikely that the new company will dismiss the previous line of products because, of course, they minimize competition. And this has happened a lot of times already. It happened in the past, for example, when Google acquired Revolve. Revolve was a very successful company producing smart home apps, which actually was allowing to control many smart home devices at once with a single app. But to function, the hub required a permanent connection to the cloud service. And as soon as Google Nest bought Revolve, it shut down the cloud services of Revolve. And then all the devices, they had to be thrown away. They were bricked, essentially.
Mm.
And the very same happened when Fitbit acquired Pebble. Pebble was manufacturing smartwatches. And also in that case, it didn't take long until support for all the various services and tools stopped. Yeah, so now there is not much you can do about this. I mean, but again, the previous recommendation still holds. Try to design a product such that it can work independently on anything which happens to the manufacturer. So don't hard code extra services unless really necessary. So this is the important thing here.
There is a small
Yeah.
question, like there is a keyword which pops up now 2 times actually in our questions. This new standard Matter. I don't know how much you know about it and how much you're in the design of that. Like it's not like now it's there, but we still don't really have too many products with that.
Yeah.
So the question is whether this standard will somehow help us in that matter, or matter help that matter.
Mhm. Yeah. I mean, I'm not an expert on Matter, but of course, it promises at least that, right? So it could help a bit indeed to change this obsolescence. The main issue here is that the standards, they come and go all the time, right? It's very hard to say, yeah, this will stick. So there is a hope. So yes, this is the answer to Jens. Probably, maybe it will help, but I wouldn't put my hands on the fire about that, because in the last 15 years, I've seen so many standards coming up and promising everything, and then yeah, just not delivering as they should. And also, there are so many technologies. There is such a diversity that yeah, it's very hard to to impose basically a common rule for everything, right?
Yeah, yeah. Thank you.
Yeah, welcome. Yeah, and the one last comment I have that I want to make is about the diversity. Actually, it's about this. It's about the large diversity of IoT technologies. And because this is also something which may lead to a lot of e-waste, which is unnecessary. In fact, we require many additional devices just to have a bridge between devices speaking different languages. Well, namely, they're using incompatible technologies. For example, consider the classical smart home scenario. You have a smartphone and you're supposed to control a smart light bulb, which is using ZigBee. Bad luck, because typically smartphones don't support ZigBee. They support Wi-Fi, they support BLE, ultra wideband, but they cannot really talk ZigBee. And so the two devices, they cannot interact directly. So what you need to do, you need to buy a gateway, you put it in between, it acts as a bridge, and then basically you convert between Wi-Fi and ZigBee, so to say. Only in this way the smartphone can control the smart light bulb. Now, if you have different devices from different vendors, the game continues. You have to buy different gateways, you have to add them, and so on and so forth. Of course, you might be lucky. There are some devices which you can control directly. For example, the BLE ones at least should be compatible with most smartphones. But even then, they can talk to your smartphone, but they cannot talk to other smart home devices. And so, yeah, if we want to have some interaction, there is no way around it. We need some sort of gateway. And the problem, as you can imagine, it grows exponentially. Even worse, one actually may need different apps, which can be very annoying for the user. And very often you find some users complaining about the smart home nightmare about this. Of course, what can help in this regard are smart hubs, these smart speakers, which can try to unify everything. But yeah, well, then one needs to hope that all the devices you have are compatible. And we just seen an example that if you get something obsolete, then it's not supported, and then you have to replace it anyway. And moreover, if you then depend on one single device, then this becomes a single point of failure. If Google or whoever shuts off support, you are done with it. It's also a bottleneck for the system because everything is going through that. So it's not ideal. And actually, what would be ideal here is to be able to directly communicate across all the different devices without any gateway, without an additional device. And this would allow devices to coordinate among each other directly. So we don't need to buy useless hardware. Now, actually, I have a good news at least, because one can achieve that, because there is a new paradigm called cross-technology communication. We actually could be helpful in this regard. And cross-technology communication, CTC in short, has recently emerged as a promising technology because it can allow a direct interaction between devices which have an incompatible physical layer. And they can let them talk directly without any gateway and without the need to change the hardware. So for example, if we take IoT devices using the 2.4 gigahertz band, like Bluetooth, Zigbee, or Wi-Fi, one can actually use cross-technology communication to let them exchange data seamlessly on the same frequency channel. And this is exactly the idea I described in the previous slide. Now, how does this work in practice? There are two main options. One option, which is the simplest, is called packet level modulation. And basically, it consists in encoding information in the timing of the packets, which are sent over the air. It's very simple. So basically, a transmitter controls the length of the packets by changing the payload. So you basically generate bursts in the air, energy bursts in the air of different duration. For example, if you want to send a 0, you send a short payload. If you want to send a 1, you send a long payload. And then basically on the receiver side, you can do some signal strength sampling, and you can basically detect how long these energy bursts are in the air. So basically, create a side channel. And since actually every wireless device, no matter which one, it can always transmit the packet with arbitrary length, and it can always do some sort of signal strength detection, then actually you can exploit this approach to let any device talk to each other as long as they are on the same frequency. The second approach is a bit more complex. It's called physical layer emulation, and an example is shown here in the slide between BLE and Zigbee devices. The idea is that you emulate a Zigbee signal and you put it as a part of a normal BLE packet, and then basically the Zigbee device will ignore the BLE part because it doesn't speak BLE, but then it recognizes what is in the middle and say, "Oh, this is for me," and then it basically decodes it correctly. It's very nice because you can be very fast. You can actually use the full speed of the receiver technology. So in this case, 250 kilobits per second for Zigbee. But of course, there are pros and cons for each approach. So physical emulation is very fast. So you have very high data throughput, but it's very technology specific because it depends on which technology you're talking to. So every combination has to be adjusted. And also, it typically only works from faster technology to slower technology. In contrast, packet level CTC is lower, but at least it's more generic. You can even support bidirectional data exchange. Actually, you can even support broadcast exchange. And this is exactly what we did in our group. So what we created is a prototype of a smartphone, which is using a Wi-Fi radio to send a broadcast, which can be received both by Zigbee uh, and Bluetooth devices around. So it was, for example, received by a Zigbee IKEA light bulb and the BLE-based smart door lock. So with one click on the smartphone, you could basically turn on the light and open door lock at the same time. No gateways, no additional devices. It just works out of the box thanks to cross-technology communication. So again, I'm not going to go into details on this, but if you want to know more, you can check out the video of our prototype on the internet.
Sounds very interesting.
Yeah, at least it's an attempt to reduce unnecessary devices, at least.
Yeah.
So indeed, CTC can help us for that. And what can also help us is in the scenario I showed before. Because if you have a device which is obsolete, all you need to do is to update the software stack of the smart speaker to have not just the native radio stack, but also the TTC stack. And then the smart speaker can use the native stack to talk to device BCD and the CTC stack to talk to device A. And again, you don't have to change anything. You just need to update the software stack because the hardware is the very same hardware as usual. At least in principle, this is possible with the software update. And finally, there is one more cool thing you can do if co-located devices can talk to each other, and namely, you can improve coexistence. You can avoid that the devices they mutually interfere with each other, because if you can basically have IoT devices that exchange information, they can make a smart channel selection. For example, imagine you have three smart home devices which are operating in the notoriously crowded 2.4 gigahertz band. You have a smart door lock which is using BLE, a smart thermostat using Wi-Fi, and a smart light bulb using Zigbee. If you use CTC, you can say, okay, the Wi-Fi device says, hey, I'm using Wi-Fi channel 1. The other devices know that. And for example, in response to that, the Zigbee device can say, okay, then I'm going to switch to channel 24. It doesn't overlap with that, and then we are good. And then the BLE device can then say, good to know. Then let me update my channel map such that I will hop across different channels, but not across those ones. And this is very powerful because it avoids a lot of coexistence issues, a lot of frustration among the end users, and ultimately we don't have to have devices which are malfunctioning and get basically thrown away from the window because they are poorly performing, so to say.
So in some way, like there is also a question here. In some way, your CTC, like this cross technology communication, can even help with the interference problem.
Yes,
Oh,
because
because there is the question is the opposite. Like, will it actually not make it even worse?
I mean, of course, you are communicating more, so in a sense, you are generating more interference, but you actually don't need too much information because if you think about it, if you have a smart home and once a day the device tells me, "Hey, I'm using channel 1," and then I know it, I just need to communicate once, and that's pretty much it. We agree not to interfere with each other, and that was just a few bits. So, of course, if cross-technology communication, especially for packet level encoding, this is a very kind of spectrum unfriendly, but you don't need to use it very often. And on the contrary, if you use it smartly, you may actually end up uh, reducing interference eventually.
Cool.
Yeah, so actually we are at the end of my talk. So let me just summarize what we discussed and what I hope you take away from it. We are in the middle of the IoT revolution. So we should expect hundreds of billions IoT devices in the coming years. And all these IoT devices are essential to solve the key global challenges and to achieve many of the United Nations Sustainable Development Goals by 2030. And while this is very attractive because it will improve sustainability, we need to make sure that we also focus on the sustainable design of IoT products in order to avoid the so-called IoT, Internet of Trash, with tons of e-waste caused by IoT devices. And to do that, a few recommendations that we've discussed are: number one, always aim to build useful devices. Try to design them in a way which simplifies their recycling. Add firmware over-the-air mechanisms to keep the device up to date so that you can prolong the usable lifetime. Ensure robustness to all sorts of harsh RF environments, and do that by using adaptive and robust protocols, because in this way, if the device is working correctly, the user has no incentive to throw it away. Avoid hard coding services which may break the device if they are shut off. For example, all these cloud services which are uh, basically gone if the company goes bankrupt, and then basically the device is bricked. Avoid using additional gateways if possible, while ensuring support for legacy devices. And we've seen that cross-technology communication could be a help for that, or at least an option. And finally, a more general consideration, try to aim to build long-lasting devices, which possibly don't run on batteries. Try to consider using battery-less devices which are trying to harvest energy from the environment, because in this way, we can really ensure a great match between IoT technologies and sustainability. No, that's it.
Wow,
Thank you.
great. Thank you. Thank you very much. This was, especially the last slide, that was amazing reference and what to do, how to do it right, or at least to try to do it right. I think we'll take one or two more questions. Like there was one which is quite interesting. How is this cross-technology communication related to cognitive radios? Like you probably remember what cognitive radios were. And like it's a little bit different, but how related are both ideas?
Actually, it's a good question because at least the very first versions of CTC protocols, they actually were developed on SDRs and software-defined radios and also cognitive radios. Now, the CTC is actually nothing more than a side channel. So in a sense, you are kind of developing some sort of additional means of communication. The cognitive radio typically tries to for example, for RF interference, you try to sample the spectrum, try to make some intelligent decision to avoid interference. In this case, with CTC, what I would propose is you make an explicit decision. There is no need for intelligence. You tell me what you're using, and we coordinate in a very explicit way. So in a sense, the cognitive radio tries to infer everything from different sources. The difference with CTC is that you directly say it without the need of any kind of misunderstanding. You use channel 1, I use channel 2, and we are good to go. So this is probably the main difference between the two, I would say.
Cool.
I'm
Yeah.
not sure if it answers the question, but that's
Oh, I think it does.
my take.
Yeah. Thank you. Okay, we're already a little bit over time, and there are no really urgent questions still hanging around. And many people are saying thank you and a very good talk. I can only confirm that it was very nice overview of this paradox, and I think for especially for students and for people who are starting as in the IoT domain, this can be a very, very interesting visionary talk. So thank you again for being with us. To everybody else, please subscribe to our channel. Please bookmark somehow the webpage where we are announcing also the next talks. You can see there, at least for the next 2 or 3 months, what is coming up. This is the website which is here currently written in the running text, connectthemall.net. And our next talk will be then in the beginning of April. And that will be Marco Zuniga with Sunlight for wireless communications. Also a very interesting talk, a very elegant solution. I will not spoil anything more. So, Carlo, thank you very much.
Thank you very
And
much for
everybody,
attending.
then goodbye.
Goodbye.